Okay. Hello friends. In this video, I am going to solve a problem on perceptron network. Here we have given with AND gate function. So we have to perform perceptron network for bipolar units. Means we have to use bipolar function for performing this perceptron network. So there are no weights given initially in the question. So we will be assuming the initial weights and bias and threshold to 0. So that is initial weight W1, W2 and bias and threshold theta will be equal to 0, and learning rate alpha is also not mentioned in the question. So the default value for perceptron network of learning rate is alpha is equal to 1. Now, the first step is we need to calculate the input value for each and every inputs given in the question. We have given 4 inputs. So now let's find input values for the first one. So the formula for calculating the input is Yin is equal to bias value plus X1 W1 plus X2 W2. So bias value is 0. X1 is 1, W1 is 0, and X2 is 1, and W2 is 0. So we got Y as 0. Now we have to calculate the output Y. You have to find out this. So we will be finding out the value of Y through the function which was mentioned in the question. So they have given bipolar. So we have to use a bipolar activation function. The bipolar activation function is Y is equal to f of Yin is equal to 1 if Y greater than threshold, 0 if Y is equal to threshold value, and -1 if Y less than the threshold value. Here our threshold value is 0. So we have got Y is equal to 0. Means our threshold value is equal to the Y value. So our Y value will be 0. Implies Y is equal to 0. Now what we have to do is we have to compare the target value. So let this be target value. So the actual value of Y is 1, but we have obtained Y is equal to 0. So the obtained value is not equal to the targeted value. Now what we have to do is we have to update our weights. Initially we have assumed 0, right? So with that assumption we did achieve our target value. So we have to update our weight in order to achieve our target value. So now weight updation formula in perceptron network is W of U is equal to old weight plus alpha learning rate into target value into Xi. Xi in the sense either this X1 or X2. So let's found new W1. So W1 of mu is equal to W1 of old is 0. 0 plus learning rate is 1. 1 into T, target value is 1 into X1. X1 is 1. So our new updated W1 is 1. Similarly, find W2 new. Old W2 is 0 plus and alpha 1 into target value 1 into H2 is 1. So 1. We have to update the bias value also. Bias value B of mu is equal to B of volt plus alpha into T. So volt bias value is 0 plus alpha into target value 1. So 1. Now with these updated weights, we have to find the input value for second one. So our new updated weights are W1 is equal to 1, W2 is equal to 1, and bias is equal to 1. Now for input 2. For input 2, the x1 is 1, x2 is minus 1, and target is equal to minus 1. X1 is equal to 1, x2 is equal to minus 1, and target is equal to minus 1. So now find y is equal to bias value plus x1 w1 plus x2 w2. Bias value is 1 plus x1, 1 into w1, 1 plus x2 minus 1 into w2, 1. That is equal to 1 plus 1 to 2 minus 1, 1. Now we have to find y value. So since y is equal to 1, based on the activation function of bipolar in perceptron network, we will be getting one if y greater than theta, 0 if y is equal to theta, and minus 1 if y less than theta is our bipolar activation function. So we achieved one, right, which is greater than 0, which is greater than threshold value. So our y value will be 1, but our target value is minus 1. Here also we did achieve the condition y is equal to t. Here also we got y not equal to t. Now since we got y not equal to t, this is the condition where we need to update our weight. So again we have to find new weight for W1. So old weight is 1 plus and alpha is 1 into target value minus 1 into x1, 1. So 1 minus 1 we will be getting 0. And W2 old weight is 1 plus and alpha 1 into target value minus 1 into x2 is minus 1. So 1 plus 1 we will be getting 2. And bias value B of mu. Old bias value 1 plus alpha into target value minus 1, getting 0. So now with this new weights and bias value, find the input value for third input. For input 3, if you remember the question, x1 is minus 1 and x2 is 1 and target value is equal to minus 1. Now find after the second input, we have got the new weights, right? So our W1 is equal to 0 and W2 is equal to 2 and bias is equal to 0. So let's find input value. bias value 0 plus x1 minus 1 into w1 plus x2 1 into w2 2. So 0 plus 0 plus 2 will be getting 2. Now see the bipolar function. Y is greater than threshold value. So y is equal to 1. But our target value is minus 1. Here also we failed to achieve the condition y not equal to t. So now we have to update our weights. So our new weight after the input 3, W1 of new is equal to, our old weight is 0, right? 0 plus alpha 1 into target value minus 1 into x1. x1 is minus 1. So we will be getting 1 here. And similarly, W2 of mu is equal to, old weight is 2 plus alpha 1 into target value minus 1 into x2 is 1. So 2 minus 1, 1. And bias value B of mu is equal to old weight 1 plus and alpha is 1 into and target value is minus 1. Sorry, old bias value is 0. So 1 into minus 1, minus 1. Now with this updated weights, let's find input value for fourth input. For input 4, if you remember the question, we have given x1 is minus 1, x2 is minus 1, and target is also minus 1. Now let's find the input value. Y is equal to bias value minus 1 plus W1 1 into x1 minus 1 plus W2 1 into x2 minus 1. So minus 1 minus 1 minus 1, we will be getting minus 3. So minus 3. See, now we have to find the y value with the help of bipolar equation function, right? So if y is greater than theta, our y value is 1. If it is equal to theta, it is 0. And if it's less than theta, it is minus 1. Here we have got minus 3, which is less than 0. And so our y value is minus 1. So our target value is also minus 1. So we have achieved the condition y is equal to t. But we have achieved the condition for the fourth input, right? So now what we have to do is we have to use the same weights, and we have to see that using these weights, is it possible to achieve the condition y is equal to t for the rest of the inputs too. Since we have given only 4 inputs, and with this we have completed one epoch. So now let's see in the second epoch whether we are going to achieve the condition y is equal to t for the rest of the inputs. So second epoch, again input 1. The first input is x1 is equal to 1, x2 is equal to 1, and target is equal to 1. Find y in value. Implies y is equal to, we are not going to update weight of the fourth input because we have achieved the condition y is equal to t. If in case we didn't achieve the condition y is equal to t in fourth input 2, then we have to update the weight and perform second epoch and see with what values of our weights we are going to achieve the condition y is equal to t and how to proceed with that. If in case you have done 3 epochs and even then you did actually condition y is equal to t, then you can stop the network at that moment. 3 epochs is maximum for such things. And so now let's find in second epoch y input value for first input, and bias value is -1 plus W1 is 1 into X1 1 plus W2 is 1 into X2 1. So 1 plus 1 is 2, which is greater than 0, which means y is equal to 1 and our target value is also 1. So y is equal to t. We obtain the condition. Now let's check for input 2. See, in fourth input we have achieved y is equal to t. So, some cases we may not get this y is equal to t in our second epoch first input value. At that time we have to update the weight and proceed for next iterations. So input 2 x1 is equal to 1, x2 is equal to -1 and target value is equal to -1. Now calculate y input. So bias value -1 plus W1 1 into X1 1 plus W2 1 into X2 -1. So -1 plus 1 will get cancelled and 1 into -1, which is less than 0, implies our y value is -1. So our target value is also -1. So y is equal to t. Now let's check for third input. For input 3, x1 is equal to -1, x2 is equal to 1, and target value is equal to -1. So let's find y in value. Our bias value is -1 plus W1 1 into X1 -1 plus W2 1 into 1. So -1 -1 -2 plus 1 -1 which is less than 0, implies our y value is equal to -1 and it is equal to target value t. So, and for input 4 also, it got satisfied that we have seen in our first epoch only. So, for input 4 also, if at all the weights got changed in between these two inputs, and so at that time we have to check for input 4 also, but we have used the same weights which were used for input 4 in input 1 and achieve the condition y is equal to t. So it definitely obviously satisfied for input 4 in second epoch 2. See, for input 4 in second epoch, x1 is equal to -1, x2 is equal to -1, and target value is equal to -1, and y in is equal to bias value -1 plus x1 -1 into W1 1 plus x2 -1 into W2 1. So we'll be getting -3, which is less than 0. So y is equal to -1 and target value is also -1. Y is equal to t. So our final weights are those the weights with which we got the condition y is equal to t for all the inputs. So our W1 is equal to 1 and W2 is equal to 1 and bias value is equal to -1. So this is our final conclusion. So with these weights, we can complete the network. As said before, if it is not possible for you to complete the network, even after the completion of epoch 3 also, then you better stop the network because it consumes time to calculate manually. So this is how the perceptron network is performed. Thank you. Also note that see in the question which I have explained in this video, in that question they didn't mention particular number of epochs. So at that moment we have to perform 3 epochs maximum. If it is not possible to get y is equal to 3 within second epoch or first epoch, so 3 epochs is maximum. And in some cases, the number of epochs that you need to perform in the solution will be mentioned in the question itself. So at that time, you have to perform those many epochs which were mentioned in the question. Thank you.